Hello?
She's not here.
I know, no one else. No one else wants to chime in on that one? No. Konnichiwa? No. Hola? No. Haste Frau? Or Guten Tag. Anyway, alright. Use washer method to find the volume of a solid formed by revolving a region around the y-axis. Around the y-axis. Okay, so right here. So if it's going to be a y-axis, I got to have my terms in what?
Terms of what?
Very good. I got to have terms of x, right?
Give them some candy.
X in terms of y. Thank you. All right. So find the volume V, solid revolution generated by revolving the region enclosed. What does the word enclosed refer to? That they're equal, right? At points. Okay. By those two graphs about the y-axis. So let's go ahead and set them equal to see where they're going to be. So 2x equals x squared, right? So let's move everything over there. So 0 equals x squared minus 2x. So f that. So x minus 2 equals 0. So my answers are x is 0 and x is 2. So there's my bounds. So let's go ahead, take a look. So my bounds would be, don't forget the pi. So from 0 to x is 2, right? Yes? Okay, but now where am I bounding this at? Where am I bounding this at? The y value, right? So these are bound on the y-axis, aren't they? So if it's around the y-axis,
It's 0 and 4.
it's going to be 0 and 4 because that's where they are equal, right? 0 and 4. So I could plug this in. I could plug this in right here, this 0, into either one of these and I get 0, right?
Yeah.
Plug this one in to either one of these and I get 4. That's where I need, right there. So I'm bounded by the y-axis there. Okay, that's important. That's probably one of like the really key critical steps that you have to understand when I'm changing this from the x to the y's. I'm looking for the y values each time we do this. Okay, so now it's going to be from 0 to 4. Now, we also got to figure out which function is going to be on top, right? If we're revolving around this, right? If we're revolving around this, that means which one is going to be greater. So let's take a look. Okay, so I'm going to do a quick sketch to show you, and then I have a graph that has a nice one. All right, so x squared, something like this, and then 2x. It's going to look something like this. So that's going to be my x value, which is 2, right? And y value, which is 4. Okay, so right there, it's going to look like this. So if I'm revolving it around the y-axis, I need to have a value here. So I need to know this distance here, right? So which one with that distance there is going to be greater? Which one is going to be on top right there? So what numbers am I plugging in there? Am I plugging in y's or am I plugging in x's? I could plug in y's, right? I could plug in y. So if I plug in a y, that's going to tell me which one has the greater x, right? So let's say y is 1, because that's going to be this right here, right? 1, 2, 3. So y is 1, right? So that is somewhere in between those bounds. So y is 1. So y is 1. So plug it in there. So for this one right here, if y equals 1, so 1 equals 2x. So x is 1/2. Do the same thing over here. Y is 1 equals x squared. Okay? So x equals plus or minus square root of 1, right? Which is just plus or minus 1. So, but for the part of my function I'm dealing with, it's going to be just in quadrant 1, so that's going to be the 1. So the greater one on this one right here is going to be 1. So it's going to be this one right here is going to be my function that is on top. Yes? And I need this in terms of y. So I'm going to get it to say x equals. So my function now has to go with, it's going to be x equals y to the 1/2, right? Minus which one?
Y equals 2x, so y over 2.
So it's y over 2. All right, this is the formula we dealt with yesterday. Did I lose anyone yet? Questions? Concerns? I think how about, here we go. So here's my nice pretty graph of this too. So it's my volume is there we go. So let's go ahead and do that. So it's going to be that's going to be just y minus y squared over 4 dy. So let's go ahead. So it's going to be pi bracket. This is going to give me y squared over 2. And this is going to give me minus y cubed over 12 from 0 to 4. Yes, no, maybe? You guys are awfully quiet today.
Yes.
Are we good?
Yes.
Okay, good. All right, so let's go ahead. So 16 over 2, so that's going to be 8 minus 64 divided by 12.
Yikes.
How about that's going to be 4, 4, 4, 3, 16 over 3, right? And so it's all this minus 0, right? Yes? Okay, good. So that's going to be 24 over 3 minus 16 over 3, which gives me 8 pi over 3 units cubed. Are we liking this?
Dab.
Yes? Good? Okay, happy day.
Did you say that?
Yeah. I'm trying to
Did he say
He
dab?
wasn't trying to.
Did he really just say dab?
Yeah, I guess he wasn't trying to do
I know.
it.
The only time you're actually allowed to dab in this classroom is if you're doing a vampire sneeze. Okay? That's the only time. You know, you're sneezing in your elbow. Are you trying to cover yourself so you're... Yeah, so...
Well, Mr. Punch was stabbed.
Nobody caught that on video.
Yeah. Just
Alright.
baited them into it.
Anyway.
Don't say that so people know what you're doing.
No, yeah, someone got me making a
Make
stupid
this
anime
video
face
all
yesterday.
clickbaity and say like Mr. Pacho dabs on his class.
I know, so yeah. No, I did that like the Nico Nico Ni the other day. Yeah, it was funny. Anyway, but yeah, someone recorded it.
Do you know who has that recording?
Huh?
Do you know
No,
who
I
has
don't.
that-
Okay. Find the volume of a solid formed revolving region around about a line parallel to the coordinates of the x or y axis. Okay, so volume V, revolution generated by revolving region bounded by the graph. Bounded by the graph about the line y equals -5. Okay, so So, revolving region bounded by the graphs. Ooh, okay. Bounded by the graphs. Okay. So, if it's across the line, y equals -5, it's rotating around that, right? Okay. So, this is basically saying it's going to be like the x-axis, isn't it?
Yeah.
Okay, so it's going to be like the x-axis. So this problem looks really familiar, doesn't it?
Yeah.
Okay, good. So where are these two going to intersect?
0 and 2.
Okay, so it's going to be from 0 to 2, isn't it?
Yeah.
Okay, good. So let's take a look. So it's going to be volume equals pi integration 0 and 2. Okay, because I just did the same problems on the previous, right? Okay, good. Same functions. Anyway, all right. So now I am rotating it, so that means it's going to look like this. So let me change colors. So again, I have this, and I have this. So now, since this one is across, it's basically going to be around the x-axis, right? Around the x-axis, right? So it's going around that one. So it's parallel to the x-axis. So this one right here, I have to try and figure out which one's going to be on top now.
That's reversed from last time.
Okay? We plug into the x value in my bounds, right?
Yeah.
Plug into the x value for my bounds. So let's plug in 1. So it'd be y equals 2 times 1, which is y is 2, and y equals 1 squared. So y is 1. So therefore, this one is going to be the one on top. Okay, that one right there is going to be on top now. So for my function, it's going to be this, right? So it's going to be my 2x. So I'm going to leave this real quick. I'm going to leave it right there. But now, for this one right here, I need to talk about the radius. It's no longer just going to the function, right? It's no longer to the function.
It's from the top.
Okay? The radius of this is going to be from here all the way down.
So just add 5.
So this is going to be the new radius of this, right?
Yeah.
So it's my function plus 5, right? Because I'm adding it to it. And so if I moved up the other way, right? Yeah, it would be basically a minus. I would be taking off from the radius, right? So if I had this one above the x-axis, okay, and I'm rotating around something that's above the x-axis, I would take away from the radius. Okay, so this one, in this case right here, because it's rotating around this, it's going to be plus that value. Okay?
Yeah.
So in this sense, if I'm going to actually try and give you guys a solid number, or like something you would do, you're going to subtract what you're doing. But we're subtracting a -5 in this case. Does that make sense?
Yeah.
So and that's why it becomes a plus 5 to my radius here. So plus 5 squared minus. Now my other function does the same thing. My other function does the same thing. So it's that function plus the 5. So my function was x squared plus my 5.
So it's always like a function minus a number.
Sorry.
that's shifted.
Sorry, right there. Huh?
So it's always a function minus a number.
Yeah,
that's
that is
shifted.
going to change. It's minus whatever that is. But if it's minus the negative, you know, if it's, and depending on what you're doing, it's changing it. It's all the time when you try and do it, if you get a visual of it, try to sketch out what you're doing. That's the first thing I did when I did this problem, right? I sketched it. I was at where I was at. You know, figured out where it went to, which one's on top. Here are my bounds. Okay, you need to actually try to give yourself a visual of what it is and what you're doing, especially if this is a non-calculator part. So you can't just throw it out and be like, oh yeah, it's this and this and this. Draw it out, see what it is. Okay, they might even do something weird as the function might be below the axis. Does that make sense? So if the function was below the axis, that would change that again, wouldn't it? Okay, so let's go ahead and do our math for this. So I'm going to have, let me see, v equals pi from 0 to 2, and that's going to be 4x squared plus 1020 x plus 25 minus quantity of x to the 4th plus 10x squared plus 25 dx. V equals pi 0, 2, and I have a negative x to the 4th minus 6x squared dx, right? Yes, because my 25s go away, right? Yeah?
Yep.
Okay, so I'm going to move to the next page on this one. So negative 4x minus 6x squared.
Yeah,
What about the 20x?
the one before it didn't have.
20x?
Yeah, what did we do to that?
Oh, I didn't put it on there, did I? Thank you. Okay, I knew I was missing something.
That poor kid that gets picked last.
I know, right?
Yeah. Oh.
Yeah, there we go. Okay, so I'm going to transfer this over to the next one. So it's going to be, volume is pi 0, 2, and what do we say? Negative x to the 4th, right?
Minus 6x squared.
Minus,
Plus 20x. Dx.
there we go. Okay, so let's go ahead and do my integration for this. So it's going to be pi bracket negative x to the 5th over 5 minus 2? Yeah. 2x to the 3rd plus 10x squared, and that's going to be from 0 to 2. Yeah, 0 to 2. There we go. All right, go ahead, start plugging in some numbers. So that's going to be 2 to the 5th is negative 32. 32 over 5. Minus 8 times 2 is 16. Plus 40. Minus 0. Okay, so that means over 40. So this one's going to be 16 times 5 is 80 over 5 plus 5 200 over 5 minus 32 over 5. And that is going to be, let me see, that's positive 120. 120 minus 32 is 90, 88. So it's 88 over 5 pi units cubed. I think so. You guys could double check that for me.
No, yeah.
No, yeah, it's fine.
No, yeah.
I know you guys are like, yeah, okay, but no, seriously, I don't know
No, I was trying to race you to the answer and I messed up, went back and fixed it.
Oh, you did?
Yeah.
Oh, you messed up.
No, yeah, I literally messed up
That's
adding up
88.
those final numbers. I was racing to it and I went 82 and I went, no, and then it's 88. And I was like, yeah, there it is.
Okay, I'm just making sure that I'm double checking that I am not wrong on my number. 88 over 5? Yeah, okay, good.
This is why.
There's half my
Oh, no, uses are-
Is there, Alex, is there something for varsity soccer? Because they're both,
He's in San Francisco. I think he's at the
Okay. Alright, so this one right here. So, same thing. But now this one's wash your method, revolving around a vertical line. So vertical, what does a vertical mean?
it goes up.
Goes up and down. I know, where's your paper? Okay, so find the volume of a solid, revolve on the same thing. So now, same function again. So I don't have to go through and redo the whole thing over again. So, that means that it's same right here. Okay, so now it is revolving around a vertical line, x equals 2. So x equals 2. So now that means that it's revolving around this way, right?
Oh shit.
Wow. Epic. That's why.
Okay. So now let's go ahead and set up my problem. So I know that the volume has to be, okay, pi. Now if it's around the y-axis, right, or it's a y, so it's up and down, so it's going to be my y's, right? 0 to 4. And we know if it's revolving around this, let's go ahead and try and see where I'm going to be measuring from. So I'm going to be measuring from here to here, right? So that's going to be my new radius, isn't it? So the outside is going to be that one, isn't it? Because it's revolving around that.
Yeah.
Okay? It's revolving around that. So let's see. So that means that it's going to be that function, which is here. And so that's going to be, that's going to be my y over 2, right? Okay? So it's y over 2, but now it's a positive number here. So I'm not, am I increasing the radius or am I decreasing the radius?
You're going to decrease it. Well,
So think about it. Think about it on the other side, okay? Think about it on the other side, okay? So it is my function, right? Because my function always reads from here this way, right?
yeah.
And I'm always calculating from here this way, right? So I'm going to start with the function of 2. And it's going to be minus the other side. Because I'm talking everything from left to right. Okay? So now my function now is going to be 2 minus y over 2.
You're
Because
right.
I'm not
On
reading it,
that
yes.
side now, yeah.
I'm not talking about the area on this side anymore. Okay? I'm not talking about all this right here. I'm talking about on the other side over there. So it's going to be the function of 2 minus whatever I have from here. Minus that area right there. Did I confuse anyone yet? Did I lose anyone? Please, if you have questions, this is probably like one of the most complicated parts of this that we're dealing with. Because you have to be able to grasp the idea that it is not just the regular function anymore. Because I moved it to the other side, I'm no longer dealing with from here to here, the space from here to here in black. I'm dealing with the side over here. Okay, so I have to subtract whatever that function is now.
So then if it was on the other side, it would be just the function
Okay, so help me out. So where give me an x value.
Like
Where,
if it was -2.
so you're saying -2.
Yeah.
So if it's rotating around -2, think about what my function would be. My radius would go from here to here, right? So that would be my function plus 2, right?
Yeah.
Does that make
Yeah,
sense?
yeah.
Okay.
It would be the function first, and then
Yeah.
radius. Okay.
What if it was 2, but your function's on the right side of 2?
Okay, let's say you're saying 1, right?
Yeah.
So let's say x equals 1. So if x is 1 right here, right?
Mm-hmm.
And it would end up making like some weird hourglass, wouldn't it?
Yeah.
So wouldn't that be... So wouldn't that be right here, it would be from here to here, right? That would be my radius, wouldn't it?
Yeah.
So wouldn't that be from here to here, that would be the radius, it'd be my function minus 1, wouldn't it? My function minus 1,
Correct, yeah.
and at here, right here, that point right there, it would change, wouldn't it?
Yeah.
Because when that rotates it, it's going to turn into like a bow tie.
Yeah.
And on the other side over here,
Would that be 1 minus the function then?
yep, the other side would be 1 minus the function.
Yeah, okay.
Does that make sense to you guys now?
Yes.
With the visual, always try to graph what you're doing. So you can look at it and try to see, okay, my radius would be from my line out to the function. That's what I was getting, right? Okay, good.
Wait, so then it matters the sides, like
Yes.
the position of the.
Yes, so watch, I'm going to do another function this time. So I'm going to just sketch something else. Okay, so let's say my function is going to be something like this, okay, right here, and it's going to be, the parts intersecting are just going to be like, let's say here, okay, so from B to A, okay, all right. So here's my functions, right? So I have this function here, and I have a straight line function, right? Okay, so it'd be in between there. So now I'm going to make my right here. Okay? So I'm going to make my line right here. And let's change my A so this actually makes a little bit better. Let's change the A to right here. Okay? So, now that we have that, so if I'm rotating around this, what would that radius be? It would be my outside function, right? And I went and let's say this is 2, okay? And this is, let's say that's 5. So the radius as it rotates around, would be this function of 5, right? Minus 2. Yes? Okay. And then the inside, right there, right? It would be the function, the radius is going to be the function, right? Minus 2, because I made my radius smaller, didn't I? By shifting this up this way, it would be minus 2.
So when is it 2 when is it 2 minus or minus 2? Like how would you determine?
Depending on where it's going to be rotating at, according to my function. So if I'm rotating it, hold on, let me get a new page. All right, so okay, so let's go back to this one right here. So here's this function, and I'm bounded by there. So if I'm rotating it on this side, okay, so if I'm rotating it around, okay, and it's going to be on the right-hand side of the function, on the right-hand side of the function. So if I'm rotating it this way, right? Right? I'm rotating it. So it would be the radius of this one, right? Okay, so radius minus this one, right? So it would be this number, which would be, let's call this one D, right? So it'd be D, so the radius would be from here all the way, right? Yes? D minus whatever the function is, right? So this is this number right here minus this other function, minus the function, because you're on this side of it. Now, if I was on the other side, so let's say I'm back to right here. Okay, I'm back to right here, or even better, I'm over here. Right? Negative D. So now, the function goes from right here to right here, right? Right? So this is the function plus D for my radius, isn't it?
So if it's on the right of the function, it's always going to be that number?
Yes, it should be the number minus the function.
And then if it's on the left, then it would be the function minus the number.
Minus the,
If it's on the left, yeah, minus the number. So yeah, so it's like that, yeah.
That's so confusing.
I know, that's the reason why I'm explaining this and not just doing the problem. All right, so let's keep going. So the second one would be what?
2 minus third of y.
or one.
Or yeah, y.
And then D1.
So 4 minus this times that is negative y times 2 negative 2y plus y squared over 4 minus parentheses 4 this times this 2 4 y 1/2 plus y, yes, and that's come on, dy. So clean it up. Plus 4 minus 4, that goes away. Why do I have this right here? What's that?
I don't- Did you put it twice?
Oh, I did. I'm sorry. Okay. All right. So yeah. Okay. Yeah, that one's still fine. All right. I have that minus 2 minus 3 y y squared y 1/2 plus 4 y to the 1/2, and then I go with plus y squared over 4dy.
Put the minus y. Yeah, that with the negative y.
Yeah, I took care of it here, right? Okay, so I'm gonna go to the next page again. So help me copy that back down. So pi 0, 4.
Minus 3y.
That's what I remember.
Yeah, it's
Plus-
about far.
Plus 4y to the 1/2
Yeah, there it is.
Yeah.
And then the
plus y squared over 4 dy
Wow.
over 4
Yes?
dy.
dy. Yep. Okay, good. All right. So it's going to be pi bracket negative 3y squared over 2 plus 8 over 3y to the 3 halves plus y third over 12 from 0 to 4 pi a negative 24 plus 64 over 3 3 and 16 all minus 0, right? So this 3 is 60, 72 over 3 plus 64 over 3 plus 16 over 3. Is that 80? So it's going to be 8 pi over 3 units cubed.
That's the same we got when we did it just around the wax.
Yep. Okay. All right. Like and subscribe. Sorry for working out that last part of the problem so quick. I'm almost out of time.
No, that wasn't on the